Hey everyone. Today I will be discussing the self-sovereign identity capabilities of our product, Hypersign, through a demo of ticketing use case. My focus will be on highlighting the security and trustworthiness of verifiable credentials in transferring, storing, and sharing data. I will describe how this technology may assist businesses in adhering to the latest data protection laws, as it requires user consent while sharing any data to third-party services. In the end, I will also showcase the demo of our privacy-preserving offline ID verification, featuring advanced privacy-enabled elements like selective disclosure, zero-knowledge proofs, and more. So let us log in as an event organizer and try to issue ticket in the form of a verifiable credential. Verifiable credentials are basically digitally signed documents which contain claims about users that are verified and attested by an issuer. However, in order to issue these credentials, first what you need to prepare is the schema. So schema is basically a data model for the credential. So let us first create one event ticket schema and publish it on the blockchain so that any issuer may use this schema to issue tickets. So we'll go to the schema tab and create our schema. So let us call it as the event ticket credential schema for issuing tickets. So our schema may have ticket may have a name, a venue, the date, right? And that's it. So let us try to issue our event ticket schema. And we are issuing our event ticket schema on the blockchain, meaning that third-party apps may also issue and verify tickets using this schema. So now that our event ticket schema is issued, we can quickly check the structure of the schema on the blockchain as well. We go to the blockchain and see what are properties that it has. So it has name, venue, and date. So now let us use this schema to issue a credential to the user. Here, the first thing that we have is a subject DID. So subject is nothing but the holder or the user. So for the purpose of this demo, I will issue this credential to myself. So I'm going to use the self DID, meaning that I'm going to issue this credential to myself, and then I'm going to select the schema. So we have just created the event tickets credential schema. So we're going to use that schema here, and then we definitely have to provide all the claims, so let's provide the name of the event. So let's say the event venue is in Goa, and the event is going to happen on the 10th. And every credential that we issue by default has one field called expiry date, meaning that the credential is going to expire on which date. You may wish to revoke the credential as well before the expiry date. We will come back to that a little later. Let's set the event date as the 10th, and let's set the expiry date as the 11th. So after 11th, you cannot use this credential. Now we will issue this credential. So whenever we issue the credential, we basically attest those claims on the blockchain as well. So the status of the credential is written on the blockchain. And as an issuer, if they want, they should be able to revoke it. Once a credential is revoked, you cannot use this credential. So we have just issued the credential, but it is not yet sent to the user's wallet, meaning that user has not yet received it. So in order for the user to receive it, we will generate a link and share it via either email or some other communication channel. There is one more protocol which may use to share this link securely, known as the DID communication protocol, but that is out of scope of this demo. So let's say we generated the link and we can send this link to the user, and user has clicked on this link. They can now click on this Accept Credential button and download the event credentials into the wallet. So now, this is my wallet interface. We call it as an ID wallet, where we store all our credentials. So I already have credential issued by various issuers, and now we have hold this event ticket as a credential. So now I will go to the event venue location and will present my ticket to the security, who are also known as the verifier. Before I jump into the verification part of this demo, I just want to quickly show you what exactly is being written on the blockchain so that we are sure that no private data revealed on a public chain. So for example, this is the credential status document which we had just written on the blockchain, and as you can see, only the Merkle root hash of the credential is actually stored on-chain. No personal information is stored. This Merkle root is now attested using the issuer's digital signature using an algorithm that issuer wishes to use. We support multiple different algorithms for security and flexibility. How exactly does the credential look like in a private setting in the wallet? The document, which contains all your claims, you have the proof of the issuer, because issuer is issuing the credential. And issuer is issuing the credential to whom? The issuer is issuing the credential to holder. So this is the DID of the holder, and this is the DID of the issuer, who is going to issue this credential. And then there is a proof. So this is the private document, which actually gets stored in either in a database or typically in an encrypted data vault, which is again out of the scope of this demo. They either store it in the secure data vault or they store it in their client app, like the ID wallet, which I have just shown. So now our issuer has issued the credential to the user, and user has also accepted this credential in the ID wallet. Now let us jump into the verification process. The user is now at the venue where they need to present their tickets and other relevant data at the gates where the verifier or event organizers in this case has to verify the ticket along with the credentials. Before a verifier verifies the ticket, he has to first request the ticket or request the credentials from the user. Now, in order to request the credential, what he needs to generate technically is something called presentation template. So the request is sent. And he needs to specify what type of ticket that he is requesting. So the type is defined by the schema. So let's select that type. Now let's say I'm requesting this event ticket credentials from the user's wallet. Please provide me event ticket. So requesting event ticket credential to let you enter. And we save this. So now this one we have created, right? So now I'm going to request. As a verifier, I will first show the QR code to the user for him to scan it and, So this is a way to request a credential from the ID wallet. The users will just scan the QR code and present the ticket now, because either I can scan the QR code or I can just press this present credential button. But you see what is going to happen here. Here, the user knows that, okay, which organization of which URL is requesting what data, and the user is providing their consent. Consent is provided in a form of a technical term called verifiable presentation, which the verifier has stored in case they need records for any sort of legal or claims purposes. So here the user presses this authorize button, meaning that as a user, I'm authorizing this organization to get access to my data. Oops, QR code seems to have expired. So there is this is again a security feature where this QR code is dynamically generated. So we will do this again. So again, I'm going to request this credential from the user. I authorize it, and now the credential is being shared to the verifier. And this time you will see that the user, the verifier, have got all the data. Yes, as a user, I have generated my verifiable presentation through my ID wallet, and I have given this to the verifier. So how exactly the verifiable presentation looks like technically? Let's see that. So this was our credentials, which was issued to the user, and the credential has one signature of the issuer. But when we look at the verifiable presentation, which is a type verifiable presentation, It contains one or more verifiable credentials or pieces of data. So it contains credentials, which the issuer has sent to the user, but it also contains the proof of the user, meaning that user has also digitally signed it. So here you can actually store these verifiable presentation for any sort of legal purposes. And verifiable presentation, you can do a lot of things, like you can enable privacy using verifiable presentation. We will come back to the privacy a little later. For now, let's focus on the point that in a verifiable presentation contains both the digital signature of the issuer as well as the user, so that user can never deny that they never given this data. So that's how powerful the consent mechanism is in order to get data from the user, because only this user holds the private key for their credentials, can provide the consent. And for the legal purposes, you can definitely store these credentials and this type of presentation, which is technically what user consent is. Verifiable presentation is technically what user consent is. Now, we just missed one point, one requirement of our organizer. The organizer not only wants to verify the tickets, but he also wants to verify the identity, that the holder of the ticket is the same as the one who bought it. They also want to make sure that all these verifications are done quickly. Otherwise, there is going to be huge of upset users at the event gates. So how do you do that here? Like, how do you link multiple credentials and share it in one go? So let's see that now. So again, we will go back to our presentation template where the verifier has defined that what ticket he wants, or what credentials, or what type of credential that he wants from the user. Let's say he also wants other credentials from the users. Now they need 2 credentials, not just one, right? So let's save that and see this in action. So we'll go back to the presentation part again, and we will request the credential again from the user. But this time, when the user tried to scan the QR code, he gets to know that this verifier is not only requesting the event credential, but he's also requesting identity card. Like, he wants to verify both of these at one flow. So you see, you can link multiple pieces of data here. You can link payment script, you can link payment receipts along with other pieces of data as well. But all of these documents are being shared in one step, meaning that you have a smooth check-in process. And there you go. A user had just chained both of this document together and shared in one flow with the verifier, right? So both of these documents have been shared. Now, did you notice that the user ends up exposing all of the personal data, along with the date of birth? So now from the user end, the user has revealed all his identity data. There is no privacy. And at the same time, the verifier now has the responsibility to store all this data, making them liable for data protection regulations. So in summary, all user data was exposed, and now the verifier has to securely store this data. So there was no privacy and no control for the user. So that is what we are going to look at next. The next part of this demo shows how we can enable privacy on top, the verifiable presentation and credentials. To demonstrate the advanced privacy-enhancing capabilities like selective disclosure, ZK proofs, I'm going to use another one of tools called Kavash, which provides APIs for offline ID verifications. Off the top, it looks like it's just another product which does ID verifications, either through OTPS, or through scanning the QR code, or through verifying IDs, such as offline Aadhaar. But let me show you how it is different. So let's say I'm going to use this QR Verify API, which basically, the user can scan the QR code on their ID card, and then we should be able to verify whether that ID was correct or not. So I'm going to copy one of the QR string which I have, which was present in my ID card, and provide it here. and press this execute button. So you can see it just provide true or false, whether this Aadhaar card, whether this QR string was correct or not. So basically what it does in the background is it basically verify the digital signature of the ID provider, and we get a response confirming whether this ID code is correct or not. However, let's assume for now that the business not only wants to verify the ID, but also wants to get some part of the data, but not all of the data. For example, the ticket organizer only wants to know the name and date of birth of the user. In order to offer them to ensure the user the right one who bought the ticket, and also they are above 18 years of age, for example. So let's say he just want to know the date of birth of this person, not the entire data, so that there is minimal data exposure, and at the same time he is compliant with local data protection laws. So here I'm going to provide one query request where I'm going to say that PR, please provide me only the name and date of birth from this ID and nothing else, or share the proof of date of birth, nothing else. So now if I execute it again, you will see I'm not only getting verified as true or false, but also what I'm getting is the verifiable presentation. If you remember, we had created the verifiable presentation a few minutes back. Over there, we were exposing all of the data, but here, in this case, we are only exposing one piece of the information, which is date of birth. Now the organizer also needs to capture the full name of this user. So they just need to pass the query here, like this, and then once you execute it, you will see only the name and date of birth is being exposed. So did you see how you are able to reduce the leakage of information? So this is what is known as selective disclosure, that a user is selectively disclosing certain claims about himself in a form of a verifiable presentation. Remember, we talked about verifiable presentation, how we can implement privacy-enhancing feature on top of verifiable presentation. So this is one example of that. So now, as an event organizer, I have got the name, and I have also got the date of birth. So what more we can do with this? In the data sharing exercise, what we end up doing is that we end up sharing the actual data. However, this was not really needed. We end up exposing unnecessary data, putting the user's privacy at risk, as well as exposing the business to data protection regulations. The organizer just wanted to verify the identity of the user, but also wanted to know that the users are adults, in order to offer the appropriate services. The organizer needs to ensure security, as well as safety, and manage underage attendees in the right manner. So, we did not have to expose exact date of birth of this person or their age, for that matter. It was not necessary. And this is where zero-knowledge proofs come into picture. With ZKPS, we can generate proof of certain data without revealing the data. So for example, let's take this case, and as a user, I want to prove that I am above the age of 18. All I have to do is, I'll have to add one query, just like we added a query for selective disclosure. We're going to add a query for ZK proof of age, and then we are going to specify the proof has to be greater than certain number, whatever is the requirement. For example, the requirement is the proof has to be greater than 18. Now, if I execute this, it will basically generate the proof, the zero-knowledge proof from the date of birth field, that this person is 18 or not. So this, and look at this proof. This is the proof, the zero-knowledge proof of my age. Now, how the organizer can verify it. So, we do have one more API here, Verify Proof API. You can, of course, verify the selective disclosure proof, and as well as zero-knowledge proof through this API. So here all I have to pass is, I have to pass that proof, and also, I have to pass the reference ID, and then when I execute it, it will say that it's true or false. In case the user happens to, mess with the proof, then it will not be verified. So let us just summarize what we have done. So, as an issuer, we have issued a schema which all partner companies, in this case the ticketing companies, may use this schema to issue the same credential. That was number one. Then we have issued a credential using that schema to the user. As a user, then we have accepted this credential in our wallet. And then as a verifier, we request for the credentials from the user. Now from the user end, he also shared the credential in a form of verifiable presentation. In the end, we have also seen privacy-enhancing feature practically with IDAPIS, that how we can actually enhance privacy on top of existing an ID provider system. And all of this we have done using offline verification. So, I hope you liked this video and you got some inspiration that how we can technically implement DPDP into our ecosystem, right? So thank you for your time. I hope you found this video insightful, and if you need more information, do not hesitate to contact us, and we can arrange a more in-depth and focused video for your specific use case.